Okay, let's talk again about minimizing customer risk, because that is really a great framework. Remember, don't just think about your customer as the customer. Think about yourself as the customer. Think about yourself as the customer of Anderson and Darling, the customer of Jark and Barra, the customer of Liliafor. You know, they are selling you a product. The product being confirmation that your data is normal. And you need to know whether or not you can trust them. So because the power is the measure of how likely that the test is to correctly identify non-normal, it's a representation of that risk that you are taking on. 1 minus the power is the risk that you are accepting. So using these charts, we can minimize the risk of committing a type 2 error by selecting the most powerful test for our scenario. But how do we decide which test to use? So as engineers, we don't want to rely on one test. I want to throw that out here right now because it's really a good idea to define a testing sequence that steps through different tests if previous tests fail. You don't just have to use one if one passes. Let's say maybe you always do a double Shapiro-Wilk-Liliafor. That to me is probably your greatest option. Shapiro-Wilk and Liliafor. If both of them fail, then you move on to Ryan Joyner. If one of them fails, I would say you can probably take it based on this evidence. You've really got a very low chance, but again, you really want to start with the most powerful. But it doesn't mean you have to stop once you get a failing result. Once you get a passing result. Another thing is that the power of all these tests is impacted by sample size and the symmetry of the distribution. So you really do want to take a look at your sample size. Maybe you want to use the Liliafors before the Shapiro-Wilk and the Jark-Barra before the Anderson-Darling if you're doing a 70 sample size, as opposed to doing a 30 sample size where you'd use the SW and the AD first. It's really up to your organization, but I highly recommend using research like these studies that we're talking about to figure out what that order is. That way, when you're talking to a customer, they can say, well, why are you okay with failing on the Shapiro-Wilk but passing on the Anderson-Darling? Well, because the Shapiro-Wilk is a very powerful test. The Anderson-Darling isn't that much more powerful, but the power of the Anderson-Darling is acceptable in our scenario. And maybe your customers say, well, it's not for us. We're not okay with a 70% failure rate when you have non-normal data. We need a minimum of 60%. So maybe you have to increase your sample size. Maybe if your data is too symmetric, you say, well, this is pretty symmetric, so we're not sure. But the good thing is that the normal distribution is a symmetric distribution. So in order for it to be normal, it has to have a good degree of symmetry. And they'll go, oh, okay, yeah, that makes sense. Even though the power is lower because you're testing more normal data, right? So the power isn't an exact measurement. So we have to use our knowledge of statistics and normality tests and our engineering method to pick the right tests. And that's really what this video is designed for, to give you those tools.